Hi, let's talk about some special right angle triangles. And I've got a couple of them drawn out here already for us to have a look at and have a quick chat about. Okay, the first thing I want to do is be able to find the missing sides. So from this triangle here, I've already put in my 30 and 60 degree angle. I've got my hypotenuse labeled as 2 there. And I've got one side, I need to find this other side. So we'll make quick use of Pythagoras to do that. And to do so, we're going to say that 2 square is equal to 1 square plus, well, should we call this missing side x? Let's call that missing side x. So we're going to say x square using Pythagoras. So x square is equal to 2 square take away 1 square. All right. This means that x will equal to the square root of 3. If you just work that out, 2 square becomes 4. 1 square is 1, so 4 take away 1 is 3. And as you move the square, you square root over there. So it therefore means that this is equal to the square root of 3 over there. Now that we've done that, what sort of information can we get from it? Well, let's have a look. The information that we can get from it, it's quite a lot actually. We can work out what sine of 30 degrees would be. We know that sine is opposite over hypotenuse, so sine of 30 is going to be a half. We can work out what cosine of 30 would be. We know that cosine is adjacent over hypotenuse, so we know that it's going to be root 3 over 2. If you make sure your calculator is in degrees, we can check this out. Then we can work out what tan of 30 will be. Tan of 30 is opposite over adjacent, so we're going to have 1 over root 3. And if you rationalize it, I'm not going to go through rationalizing it, but you can have just root 3 over 3 if you rationalize it, okay? So they're both the same. These two are both the same thing. Okay, we can do the same for 60 degrees as well. So we can go and say, now, if we just look at the 60 degree angle, and I'll do this in a different color. The 60 degree angle, which is over here, we can find sine of 60. Sine of 60 degrees will be, looking at the 60, this is now the opposite over hypotenuse. So that's going to be root 3 over 2. Cos of 60 degrees is going to be adjacent over hypotenuse, so a half, and tan of 60 degrees is opposite over adjacent, so then that is just root 3. You can put it over 1 if you like, but that is it, and that's done. Okay, now all of these things I will present to you in a table at the end of my explanation, but you will do well to learn these. It will save you a great deal in your maths exam, particularly if you're doing further maths. They'll save you a great deal of trouble. So try and learn them. If you can't learn them, or you think you might forget, then learn to find them out the way that I've just shown you with the triangle, okay? And then you'll be able to prove them for yourself. Okay, let's move over to tan, this other triangle here. Now, from this triangle here, as you can see, again, I am missing a side, and that side that I'm missing is my hypotenuse. So I've drawn an isosceles triangle here, a right-angled isosceles triangle. So we've got one, we need to find that missing side. All right, let's call that missing side y. And so we use Pythagoras again, and we're going to say y square is equal to 1 square plus 1 square. Okay, always start with your hypotenuse. So y is equal to the square root of 2. Just to explain that, 1 square is 1, 1 square is 1, add them together you get 2, and then to get rid of the square you square root that 2. So this is root 2 there. Okay, we're going to now do the exact same thing we did with the triangle we had before. We will find sine, cosine and tan, but this time of just 45 degrees. So here we go. We're going to start by saying sine 45 degrees is equal to, well, it doesn't matter which 45 degrees you pick. Whichever one you pick, sine is opposite over hypotenuse. So that's going to be 1 over square root of 2. And then if you rationalize it, to get rid of the square root at the bottom, you're going to have root 2 over 2. Okay, so we can do the same thing for cos 45. So we're going to have cos 45. Again, adjacent over hypotenuse. It doesn't matter which one you take. It's still going to be 1 over root 2. And we can again rationalize that, root 2 over 2. Right, every time I say the word rationalize, if you don't know what I'm talking about, you need to check out my video on surds. Okay, right, particularly the second video. And then we can do tan of 45 degrees, which is going to be, in this case, whichever 45 you take, opposite over adjacent. So it's still going to be 1 over 1, okay, which is going to be 1. So tan of 45 is 1. All right, so now what I'll do is I'll put this in a nice table for you so that you can see what it looks like, and you need to make sure you memorize it. Okay, so here's our table that we can fill out. So we got 30 degrees, 45 degrees, and 60 degrees. If you want, you can put them in radians as well, but I wouldn't go into that right now, because for further maths and at this stage you wouldn't need that. But as you go into A levels, then you might need to know them in that way. So as you can see, from all the work we did over here and the work we did over there, we're just going to take that and put that nicely in a table. So I'll pause the video here and just pop them in the table. Okay, so there's the table all filled out. You might want to, I don't know, pause your video, take a screenshot or something like that, but just make sure you learn them. Okay, let's do some questions. Okay, I've got some blank triangles here, and what I'll do is fill in the information on the triangles, and I'm going to tell you about the question. So the question basically is, find the exact value of x and leave your answer in surd form. So if you have surds, leave it in surd form. Otherwise, you need to find the exact value, which means no decimals at any point in time. Keep all answers exact. Okay. Now, so let's go through this then. We've got a right angle triangle. We've got a given angle. We've got the opposite side. We've got the hypotenuse. So we will use sine. Okay. So we will say sine of 30 is opposite over hypotenuse 6. So we should start off nice and easy. Now, if you're asking the question how we know that we need to use sine, then you need to go back and revise your trig ratios or SOHCAHTOA or whatever it is that you use to remember. Okay, but at this stage you shouldn't be asking that question. You should know, what we're actually doing here in terms of using the trig ratios. Okay, as you can remember from our table, that sine of, actually before I do that, let me rearrange it. So let's remove this 6 and put it there, so it's dividing, it will multiply. So we're going to have 6 times sine 30 is equal to x. We know that sine 30 from what we were just doing is a half, so this is going to be a half there, and then you're multiplying that by 6, so it means that x is going to be equal to 3. Okay, x is equal to 3. Might as well write that properly. So x is equal to 3 centimeters in this case. Okay. Now, on the next problem then, let's see if we can up the ante a bit. So I'm going to have a 30-degree angle in here again. I'm going to have root 3 up there and x there. We can have basically anything we want, and we can just have a go at it. So we're going to find the value of x, keeping our answer exact. So let's see what we've got. We've got adjacent and we've got hypotenuse, so we're going to use cos. So we're going to say that cos of 30 degrees is adjacent over hypotenuse root 3. Then we will rearrange by bringing the root 3 over there. So we'll have root 3 cos 30 is equal to x there. And you remember from our table that cos of 30 is root 3 over 2. So what we're going to have is root 3 times cos of 30, which is root 3 over 2, is equal to x. What we'll do here, if you remember how to work your fractions, the top multiplies by the top, because this is pretty much over 1, isn't it? You know, so, and then the bottom times the bottom. Root 3 times root 3 will just give you 3, and 1 times 2 gives you 2, which gives you x there. So root 3 times root 3 is what we've just done, and it gives you 3, and then 1 times 2 gives you 2. Okay. If you're wondering how root 3 over root 3 gives you 3, I'll just do a quick aside here because somebody might not know. So root 3 times root 3 is the same as 3 to the power a half times 3 to the power a half, because square root is to the power a half. You can remember from indices. And when you multiply two indices and they have the same base, you just rewrite the base and you add the powers. So a half plus a half is 1, which is just 3. Okay, so that's how we know that root 3 times root 3 will just be 3. As a rule of thumb, if you're multiplying two square roots and they've got the same thing inside of them, just write down whatever that thing is, because the square roots cancel each other out. Okay, let's move on. So here we have another problem, and what we're going to do is we'll put all the other bits in, and this time I'm going to go for a 60-degree angle up there, of 5 centimeters there, and x there. And so with this one, we'll just go and find x. Again, keep everything exact. Don't bring anything to any decimals. Let's see what we've got. We've got the opposite side. We've got the adjacent side. So that means we have to use tan. So tan of 60 degrees is opposite 5 over adjacent x. Okay. Then we rearrange. I'm just going to do the quick rearrangement here. So x will be equal to 5 over tan 60. Then you check your table out. Tan of 60 is just root 3. So this is just root 3 here. So it means that x now equals to 5 on top of root 3. Now, as you know, we don't like square roots in the denominator, so we'll rationalize it. And again, like I said, you know, you need to know what I'm doing when I'm rationalizing. You can leave your answer like this. It doesn't mean it's wrong. It's just that we don't like leaving square roots in the denominator. But if you left it like that, you're not going to lose marks for it, okay? So we rationalize that then, and then we will have 5 root 3 over 3 centimeters. And that's the answer for that one. All right, let me draw a triangle over here and give you a couple of minutes to do one on your own. Okay, I've set you up a nice one here. I'm just putting the finishing touches onto it and basically say, okay, so here we go. You need to go and find x. Pause the video, have a couple of minutes, see what you make of it, and then, yeah, and then I'll solve it. Okay, so let's go through it and see what we should get. Now, if I'm finding x, I'm looking at this triangle here, but I can't find it without knowing this side first. So looking at this triangle at the top here, I'll label this y, and then I will go and find y first. And to find y, I'll just look at this triangle first. I've got a 30-degree angle in there. This is my hypotenuse and this is my adjacent, so I will use cos. So I'm going to say cos of 30 is equal to adjacent over hypotenuse. I know that my cos of 30 is root 3 over 2. So let me just do a quick rearrangement here and say I'm going to have root 3 times root 3 over 2 is equal to y. And yeah, what I've done is I've moved this root 3 over to the other side, so there it is, and then my cos of 30 is root 3 over 2. So this becomes 3 over 2, 2 is equal to y. Now that I've got that, I'll put that in here. This becomes 3 over 2. And then now I can go and find this missing side, that is x over there. So to find x, what I will now do, let's bring this over here. To find x, what I will now do, let's see what I've got. I've got my hypotenuse over here, and I've got an adjacent side over there to this 45. Okay, so I'll use cos again for adjacent over hypotenuse. So this now gives me cos of 45 is equal to adjacent x over hypotenuse 3 over 2. Now I will multiply by that 3 over 2, and this is now going to give me 3 over 2 cos 45 is equal to x. Now I know that my cos 45 is root 2 over 2. So, pardon me, so I'm going to have 3 over 2 times cos of 45 is root 2 over 2, and that equals to x. And it's now just a matter of, pardon again, multiplying the top, multiplying the bottom. So 3 times root 2 gives me 3 root 2, and then the 2 times 2 at the bottom gives me 4. And that's it. We're done. Yeah, this is completed now, and the answer is exact and unchanged. All right, guys, so that is all for now. I hope that you were able to pick up something from this video on special triangles. Drop me a line if you've got any questions, and thank you.